Good morning. I'm Devi Trisha from the team Zero Light. Our problem statement is an IoT-based solution for recording and storing metrics for normal and orthotic leg for analysis by orthotest. Our problem statement is divided into three phases. First, hardware phase, followed by IoT phase and classification and analysis by the orthotest. Here is the hardware setup for our experiment, which consists of MPU6050 sensor, an Arduino board, and USB cable which connects the Arduino board to the PC. And the MPU6050 has 3-axis accelerometer and 3-axis gyroscope which measures the linear acceleration and rotational rate respectively. The data extracted from the sensor is displayed on the PC. This is the graphical representation of the data extracted from MPU6050 sensor. Here we are looking at the prototype of the FSR sensor that is going to be placed under the foot. Here this is a 0.3 mm circular FSR, and since the Arduino cannot measure the changes in the resistance, a voltage divider with fixed resistance is set up here and the values from the FSR. Here as I give force, the values are generated. Thank you.
Hi, I'm Manjunath and this is Krishi. We are from Team ZLI. We just saw the first phase of the problem being implemented, the hardware phase. We are now moving on into the IoT phase of the problem. The problem with using the Arduino controller is that the Arduino needs an extra Raspberry Pi to connect to Wi-Fi and transfer the data. Hence, we are moving to use the ESP8266 microcontroller over Node MCU. The advantage is it has a Wi-Fi circuit built inside as well as power backup. We can see the circuit diagram of the implementation as well as we can see the hardware implementation below. So now, yeah, this is how we implemented it. Then this sensor works by using the MQTT IoT protocol, the Message Queue Telemetry Transport Protocol, using the Eclipse Mosquito Broker, which will be set up in our Amazon EC2 instance. From that instance, we'll be using WebSocket service from our website to subscribe to that particular topic. Right. Next, moving on to the data, we saw the structured data which we got from the sensors. Yeah, this is how it looks: gyro XYZ and acceleration XYZ. Now, from this, we are deriving a few metrics because of two things. The first thing is there is a cloud storage constraint which we want to meet. The second thing is we want to reduce the amount of redundant data. Hence, we are deriving the metrics from the data which we get from the sensors. The first one is walking orientation, which is the change of gyro, step acceleration, which is the change of motion acceleration, and the double step time difference, which measures the time difference between the double step as well as the distance it takes. Moving on, the website which I mentioned about, it will be structured in the way that we're going to show right now. Yeah, so we'll have the authentication page because, medical data is pretty sensitive data. From then on, we'll be using an interactive dashboard, which will be showing the metrics which we just derived right now for better analysis from an orthotest. We'll be building a backend machine learning model, which will understand all the derived metrics and give proper suggestions to the analysis by the orthotest. Thank you. Have a nice day.